Okay, this is student notes 11.3b, area of sectors and arc length. Yesterday we did 11.3, which was just area of sectors, and today is 11.3b, so we're just focusing on arc length. An arc length is the first thing we're going to talk about, the definition, which is the distance, because a length is a distance, so the distance along an arc. Okay, so let's say we had a central angle here, and here was its arc, right along that red. So not only does this arc have a degree, like it could be 90 degrees or 100 degrees, but it also has a length as well. It has a distance that is associated with this. Okay, its length we call L, obviously, but the degree, we learned this yesterday, we call M for measurement of degrees. Okay, so when we are looking for the arc length, we would set up a proportion just like yesterday's lesson. But our proportion for this lesson would be M over 360. Remember, M is how many degrees it is, the measurement in degrees, is equal to the length, or L, over the length is only part of the entire circle, the distance around the circle. And the distance around the circle is the circumference. So it's going to be length over 2 pi r, which is the circumference of a circle. So this is the formula we will use to find arc length. So find the length of arc FG, okay? Well, there's arc FG. 130 degrees right here, I'm sorry, 134 degrees is actually its the measurement, or the degree measurement, that would go above the 360. But we don't know what the length is. We're looking for the length. So we're looking for L. Okay, so let's set up our proportion. Our measurement over 360, so 134 degrees out of a total of 360 degrees is equal to the length, which we don't know, but it's part of the whole thing, which is the circumference, which is 2 pi r. So 2 times pi times our radius, which in this circle is 8. And 2 times 8 is 16 pi. So this is really 134 over 360 is equal to L over 16 pi. Okay, so let's go ahead and cross multiply. So we have 360 times L, which is 360L, is equal to 134 times 16 pi. Okay, 134 times 16, and then we'll attach the pi on the end. So 2,144 pi. And it wants us to leave it to the nearest hundredth, so that means we're going to put pi in our calculator now, so that we are rounding as close as possible to the nearest length. So we're going to put 2,144 pi divided by 360 in our calculator. Okay, 2,144 pi divided by 360 will give us our length, which is closest to 18.71, because the 9 rounds a 0 up to a 1. So 18.71 will be our arc length, and it'll be in centimeters, since that is what our radius is measured in as well. Okay, so we're going to save the you try after example 1 for tomorrow. Let's look at example 2. Find the measure of an arc. Okay, so this time we don't know the degree, but we know its length is 0.25 pi. So maybe here's our arc. We know it's 0.25 pi, but we don't know how many degrees it is. But we know the circle has a radius of 2 meters. So we're still going to use our proportion, but instead of not knowing the length, we don't know the measure. So M over 360 equals L over 2 pi r. So this time we don't know what the M is. So M over 360 is equal to, our length though is 0.025 pi divided by 2 pi r. So 2 times, if we put a radius here, is 2. 2 times 2 is 4, so it's 4 pi. Okay, so again, let's cross multiply. So 4 pi times m is 4 pi m. 360 times 0.25 pi would be 90 pi. And then we want to get m by itself, so we're going to go ahead and divide both sides by 4 pi. And since we're dividing by pi's, the pi's on each side cancel. But the 90 divided by 4 is what we're going to plug in our calculator. So 90 divided by 4 is 22.5. So the measure of the arc length here is 22.5 degrees. We know the length is 0.25 pi, but the measure in degrees is 22.5 degrees. Okay, we'll save the you try this for class tomorrow. Let's look at example number 3. Number 3 is a completely different kind of example because we're not looking at an arc, we're looking at finding the perimeter of this figure. Now this figure looks like it's a square and a semicircle put together. And what we're looking for here is just the perimeter of the outside, not anything on the inside. So we're looking for the semicircle plus 1, 2, 3 sides of our square. So just what I outlined in blue is what we're looking for because we're looking for the perimeter or the outside. So since it's a square, we know that this is 10, and this side is 10. But we still need to figure out what is the length or the distance of this semicircle here. Well, since we know it's a half circle, we know that it'll be half the circumference of a circle because the circumference is the distance around an entire circle. Well, the circumference of a circle is just 2 pi r, but we're only using half a circle, so we would cut that in half. So really, the circumference of a half circle is just pi times r. Well, how do we know what the radius of this circle is? Well, the radius is just from the center to the edge. And the center is right here on the edge of the square. And so the radius of the circle is half of the side length of the square, which is 5. So really, the circumference of this circle, or this half circle, this semicircle, is just pi times 5, which is just 5 pi. So the perimeter of the whole shape would be 10, 20, 30 plus the circumference of the semicircle, which is 5 pi. And we can't add 30 plus 5 pi together because they are not like terms. So we just leave it as 30 plus 5 pi inches. We are also going to save number 4 on the next page for tomorrow, so I will see you guys then.